Hi, so my topic is electromagnetic spectrum or EM spectrum for short. It's basically different kinds of lights in the universe. And when I say light, I mean way more than just what our eyes can see. Astronomers use EM spectrum like a detective uses different tools. Each one shows different clue about what's out there. So the EM spectrum stretches from radio waves that can be longer than a skyscraper to gamma rays that, as a matter of fact, is way smaller than an atom. The big difference between each type is wavelength, that's how long each wave is, and the frequency, which is how fast the waves pass by. The shorter the wavelength, the higher the frequency and energy. In astronomy, each part of the spectrum reveals something different. Visible light might show us the shape of the galaxy, but infrared could reveal hidden newborn stars inside. And X-rays might show you that there's a black hole in the middle of it. If you only looked with our eyes, it would be like reading just one page off of a 1,000-page novel. First up, we have the very low frequency or the VLF radio waves. These have incredibly long wavelengths. Think tens or even hundreds of kilometers long, and very low frequencies too. On Earth, they're used for things like submarine communications, but in space science, they're kind of like an ear tuned to the low bass notes of the universe. VLF can pick up signals from planetary magnetospheres, like the Jupiter's intense radio emissions caused by its strong magnetic field interacting with its volcanic moonwell. They can also detect bursts from solar storms and cosmic lightning events. The NASA's Radio Astronomy Explorer 2, or also known as the RAE-2, it was launched in 1973 and it's orbited the moon to get away from Earth's radio interference and measured VLF emissions from Earth and Jupiter. VLF is unique because it lets us hear space weather in action, the kind of stuff that we can't see with a telescope at all. Next up we have is infrared. It's basically the heat vision for the universe. Anything warm gives off infrared light. Even if it's completely dark to our eyes, the big advantage is that infrared can see through clouds of dust that blocks visible lights, which is very, very used for studying areas where stars and planets are forming. The James Webb Space Telescope is the superstar here. One of its images, the Herbig-Haro 4647, shows a young pair of stars hidden inside a dusty cloud, launching out these massive jets of gas. Invisible light, you'd mostly see darkness. Infrared also helps in finding exoplanets by spotting the tiny amount of heat they emit compared to the stars they orbit. I love infrared because it's literally showing us the hidden universe. It's like turning on a night vision in a pitch black room and suddenly seeing its full life. And finally, we have the X-rays. These are the opposite end of the spectrum from VLF, with incredibly short wavelengths and extremely high frequency or energy. They come from some of the most violent places in the cosmos. Think of matter devouring or spiraling into a black hole, a neutron star spinning dozens of times a second, or the aftermath of a massive star exploding. The Chandra X-ray Observatory has been our main X-ray eye in the space since 1999. It's given us images like the supernova remnant Cassiopeia A, which looks like a colorful cloud in visible light, but in X-rays, it shows shock waves and incredibly hot gas. Without X-rays, we wouldn't even know about some of these extreme environments because they just don't shine in other parts of the spectrum. So the EM spectrum is like having a huge set of different lenses to look at the universe. VLF instead, or infrared and X-rays, each give astronomers unique clues, and when you combine them, you get the full story. If we only stuck to visible light, we'd miss most of what's happening out there. And it's not just about seeing, it's about listening, feeling, and detecting the invisible. So, yeah, that's my deep dive into the three parts of the electromagnetic spectrum: the VLF, infrared, and X rays, and how each one shows us totally different side of the universe. Thanks for watching, and next slide is for my reference. That's it for me.